This video is about how to determine if a relationship is a function or not. The word function has a very specific meaning, so it's basically knowing the definition of the word. In order to see that, I think it's best to look at some examples. So our objective is to be able to tell whether a relation is a function or not. So hopefully, after you're done with this video, you'll be able to look at that table or any similar table or graph and say whether or not it is a function. So let's go ahead and look at a simple example. I'm going to keep the table pretty small just for simplicity's sake to start with. So let's make a simple XY table there. All right, so obviously this is a table of inputs and outputs. I'm just going to make a couple. Here's an input of 2 and an output of 3. And let's do an input of 1, an output of 5, and an input of 0, and an output of 5. Now this is kind of weird. It's not a line. I just kind of pulled these numbers out of the air. But this is a function. A function is, for each input, there is at most one output. So as you can see from each one of these lines, for example, this line right here, that entry in the table says that the input is 2 and the output is 3. So 2 has an output of 3. This one says that when you put 1 in, you get an output of 5. And this says when you put an input of 0, you get an output of 5. So this is a function right now. I'm going to change it very slightly and make it not a function. It is now not a function. And the kicker is for the input of 2. Because both of those lines have an input of 2, but they have 2 different outputs. If I were to say, what's the output when the input is 2, you wouldn't be able to give me one answer. You'd say, well, it's 3 and 4. And that's not allowed for a function. So this right now is not a function. Let me show you a graphical example. Here's a relation, a group of points that I connected the dots there, and of course that looks like a parabola. That is a function. It is a function because no matter what input I pick, let's say I pick an input of, let's say this is 1, 2, 3. If I pick an input of 3, there's only one output. Right there. That's the only output there is. Whatever that number is, and I can't tell by my crude graph, but there is only one output for that input. And that's true for every other input as well. It doesn't matter what you pick, whether it's way to the left or way to the right, each input I should say, only has one output. So that is a function. Now let me change this graph so that it is no longer a function. Now this is kind of a weird shape. I don't even know of what equation would make a picture like this. But this is now not a function. Let's say I pick an input of 3, this dot that I already have noted here. But now there's another output for 3. Because when I put in 3, there are 2 different options for an output. This is not a function anymore because there are 2 outputs for some input. And actually, there are a lot of places where there are 2 outputs for one input. Let's try a more complicated example here. All right, let's make another XY table. All right, for this relation, it looks like no matter what, the output is 3. So that's a table of that situation. I'm sure you're picturing what the graph would look like as well, but just in case, I'll draw it for you. No matter what the input is, whether it's -2, the output is 3. Whether the input is -1, the output is 3. Everywhere, the output is 3. This is a function. Even though there are lots of different inputs that give the same output, that's not a problem. Because if I give you any input, you could say, well, here's the output. Whenever you can say what the output is, it is a function. If you have to choose between two options, then it is not a function. Let me change this a bit. Make a different XY table and a different graph that goes with that. All right, so let's see. All right, so let me just put some points, some coordinates on the graph that match up with this. So -2, 5, the first one, will be about right here. Sketch here. -2, -6 is another point that should be here. Puts me right there. I have -1, 7, which is right there. And -1, 7 is the next one, so I'll just draw a dot right on top of that again. 0, 2 is right here. One smart word to connect those. Redo that dot there. All right. So as I was saying, we have 0, 2 right here, and then we have 1, 3. Which is about right there. So we have 1, 2, 3, 4, 5 dots there. I guess we had 6, but 1 was right on top of the other one. Now, this is not a function. That right there is not a problem. Yes, -1 as an input shows up twice, but the input is 7 both times. So it's just listed there twice. So if I said, what's the input, or rather, what's the output when the input is -1, you would say, the output is 7. You don't have to think about it, you don't have to choose. Here's the problem. That, and on the graph, those 2 points. That's the problem. If I said, what is the output when the input is -2, you'd say, well, it's 5 and -6. Because you have to give me 2 answers, this is not a function. So if there is at most one input, if there's at most one output for every input, then it is a function. All right, so I'm going to draw a couple up here, and go ahead, and once I have them up here, go ahead and pause the video and try these on your own. Let's see, the first one, let's do this table. So is that a function? Call that number 1. Number 2, let me give you a graph. This is completely separate from number 1. So there's that graph. Is that a function? Let me give you another graph. Kind of a zigzaggy line there. So go ahead and pause the video, try each of those, and try to decide whether or not those are functions. All right, so hopefully you've had a chance to attempt those problems. We'll see how you did. The first one. Yes, it is a function. Let me go back and show you why. I was trying to make things a little bit tricky with these two entries in the table right there. It seems like it should be the place to focus. But if I said, what's the output when the input is 3, you'd just say 7. There's no problem there. Number 2. That is also a function. Let's go back and take a look at it and see why. Number 2 is a function because there's no place on that graph where I can give an input and there are 2 different outputs. For example, if I gave the input 3, there's the output. If I gave the input -1, there's the output. There are never 2 options. There could be 0 options. That's completely okay with a function. Like for number 1, if I said, what's the output when the input is 4? Well, there's nothing listed in the table for an input of 4, so you wouldn't know what to say. And that's okay for a function. It's okay to say, no, I don't know. It's not okay to have 2 different answers. All right, number 3, the last one. That one, as you probably guessed, just because we had 2 yeses in a row here, that one is not a function. And here's why. There are a number of locations, but for some of these inputs, for example, maybe 5, I guess, here. That looks like it has an input of 5. That looks like it has an input of 5. All those 3 red dots that I just drew there are red on top of each other. Those are 3 different outputs for the same input, and that is not okay. You can't have 2 outputs for the same input. You can't have 3. So to convince somebody that I know what I'm talking about, to explain my work, it's pretty simple. Yes, only 1 output for each input. And the same thing for number 2. I'm not going to write it again because that's sort of just proving that, yes, I know why it is a function. So same reason for number 2. Ditto. Number 3, though, there are more than 1 output. There are more than 1 outputs for an input of 5. And that was just one that I could have picked. It looks like there were a couple other ones, but the one that I looked at was 5 with these 3 red dots right there. That's one place where there are multiple outputs for 1 input, which makes it not a function. So, do you know what a function is now? Can you say whether that table is a function or not? If you can, great. I think you're ready to move on to the next thing. If not, then watch the video again or search for other YouTube videos that might explain this in a different way, or try to find a website that might help you out, or ask me in class for some other ideas on how you can get a firmer grasp on what a function is.